So I'm Tian, and today we will talk about OpenTelemetry.jl, collecting logs, traces, and metrics together. My talk will first give a basic introduction to OpenTelemetry, and then we will go through the implementation details of OpenTelemetry.jl, including logs, traces, and metrics. And then I will show you a typical example with HTTP.jl. And last, we will talk about best practices and the real-world challenges. So OpenTelemetry is a whole ecosystem. It is focused on creating data, collecting data, and also transformation of the telemetry data. By creating and generating data, the data may come from microservices and also may come from the shared infrastructure like the Kubernetes and also the cloud services. By transforming and collecting, we mean OpenTelemetry Collector is a standalone executor, and it can be executed as an independent service. It will collect data from a microservice and also the infrastructure. And beyond that, it can also be used to filter and compression of the telemetry data. And then it will can send the data to several different databases like ClickHouse, Elasticsearch, etc. So today we'll focus on the OpenTelemetry.jl. It is a Julia implementation, and I will mainly focus on the microservices part. So when should you consider OpenTelemetry.jl? Usually you will already have a distributed system, and probably with many different programming languages included. And you also want to avoid vendor lock-in. Third, obviously, you would like to collect the data in Julia and across logs, traces, and metrics. If you only need to collect logs, the best choice would to just go with logging extras.jl or something like this. But if you would like to collect the three different kinds of logs, then OpenTelemetry.jl is a better choice. The main benefits of using OpenTelemetry is, first, it allows you to own the data that you generate rather than be stuck with an appropriate data format or tool. Second, it allows you to learn a single set of APIs and conventions. And third, most importantly, is that OpenTelemetry is now quite stable. The logs, traces, and metrics path specifications are all stable, and the OpenTelemetry Collector protocol at version 1 is also released. Now, let's talk about the Julia implementation. The OpenTelemetry.jl itself is a monorepo, so it contains several different sub-packages. The fundamental one is the API.jl. And based on it, we built several concrete implementations, and the implementation are all included in the SDK layer. By combining SDK.jl and the OpenTelemetry Proto.jl, we have provided many different exporters like the HTTP layer exporter and also the gRPC layer exporter. Beyond that, we also have independent Prometheus exporter. Also, we use the newest feature of package extension in this package. So we have several extensions like download extensions and HTTP extensions over the API.jl. And also we have a term extension to help us visualize the data structures in SDK.jl. From a functional view, we can see that first, the API layer defines the whole interface, and then the SDK layer implements the specification. Third, the proto.jl encodes all the concrete types defined in the SDK, and we use protobuf to encode the data into binary. Note that the proto.jl is automatically generated based on the proto files from the official OpenTelemetry specification. And the last step is to emit the data. For now, we have only the latest version only support emitting data through the HTTP, and the gRPC part is currently unavailable. So how to collect logs with OpenTelemetry.jl? Here I provide a simple example. So first step is by using OpenTelemetry. By default, it will initialize the OpenTelemetry logger and then update the global logger, and then we set up the default exporter. The second line, we can use the term. So this line is optional. It is only for beta display, and it will trigger the package extension here. And the rest are just straightforward. So you log and you will print the error message. We can take a deep look into what's happening under the line. So when we are printing the info message, first it will be applied to a log transformer and transformed into a log record in the left picture. And then the log record will be applied to a log exporter and sent to I/O. So if you are familiar with logging extra.jl, you can think that the log transformer is just a concrete implementation of the transformer, and different logger exporters are just the sinks. If you are not familiar with logging extra, that's okay, because the next talk, Cassie will give it introduction in detail. Note that the logger in OpenTelemetry.jl can also be used in conjunction with other loggers provided in logging extras. So I highlighted several important fields here. The body field is the content of our logging message. And also we have a trace ID and span ID. By default, they are all 0, and we'll come to it later. For the attributes field, if we provide some extra key value pairs, and after the hello world string, they will also appear here. So in the attributes here, they are all empty. For the traces, to collect traces with OpenTelemetry, we can simply call the with span function. The variable in the first variable providing the with span function is the span name. And here you can use the dual syntax to wrap the call logic here. So as you can see, the span can be listed in parent span. And also note that if you wish, we can also create many parallel spans here. So when we execute the with span, it will first call the create span, and it will try to find a span context from the current task. If it is found, then it will inherit it from it and create a new span ID. But if it is not found, then we will create a fresh new span context. At the end of each span, we will update the end time and trigger the span processor. Within each span, we can also do a lot of things like update the attributes of the span, or add links or events to the span. Okay. Some advanced usage are like we can also do some trace sampling. For example, by default, we will use ratio-based sampling, and the default ratio is 1.0, which means we will always sample the trace. But you can also implement your own customized sampling methods. And you can also customize ID generation. And by now, it is random number. And you can also try to generate specific trace ID based on your business logic. The third part is collecting metrics in OpenTelemetry. To collect metrics, usually we will create a meter first, and then we create different kinds of instruments like a counter and associated counter to the meter. Usually we will create many different meaningful similar instruments so that they can bundle together into a meter for better management. And then we have the counter now. We can just execute it by providing key value pairs, key value arguments. We can specify the attributes of this counter. And finally, we can call the metric reader to read the latest value of those instruments. Here is a detailed explanation of the metric data structure. The most important one are the name of the fruit counter, and also there are many data points. So it is a hierarchical structure. The topmost layer is a meter provider, and then for each meter provider, we have several different metrics. And each metric is just a pair of instrument and aggregation. By default, we have implemented three kinds of aggregations like sum, the latest value, or the histogram aggregation. And each aggregation also have many different data points. And as you can see, the data points are distinguished by their key value pairs, the attributes we specified before. So also, we have several advanced usages with metrics, like we can define the views. The reason we need views is that if you are in a large project and you have a lot of dependencies included, then each dependency may provide many different kinds of metrics. But for specific application, you will only need several kinds of metrics you are interested in, so that in that case, you can specify the views and filter metrics by instrument type or the instrument name or the meter type and name and also the version. Also, you can filter the metrics by attributes so that some extra attributes are not included. Beyond that, you can also customize your own data points. Like you can specify the histogram bounds, or even you create your own data point type. Okay, so we have talked logs and traces and metrics, but how they are correlated. Here, in a standalone Julia process, they are correlated with the trace ID, span ID. For logging, we have dedicated fields of trace ID and span ID. And for the tracing part, the whole span context is included in each tree, in each span. And for metrics, the span ID and trace ID are included in the exemplar. But how they are correlated across services? Like we have service A, and it may be written in Python, and we have another service named service B, which is implemented in Julia. To pass the information from service A to service B, first, usually we will have to extract the current context from the current service and then deserialize it through some kind of approach. And then once service B receives the data, it will try to deserialize and inject the conveyed context info into the current task. For HTTP, we can try to pass the trace context information through the specific trace context header. And if we are using gRPC, we can put the context info through the metadata. In some async event messages, we can pass, for example, the cloud event format, we can pass the context through key value pairs and inject them into the message. But unfortunately, for example, in distributed.jl, it doesn't provide such kind of metadata to allow you to convey the context info, then you have no choice but to implement your custom data structure. Now we can go through a typical example with HTTP.jl. The left part are the common code in both the client side and the server side. So it first will set up the global logger, a global trace provider, and also a global meter provider explicitly here. And for the metric reader, we use the periodic metric reader here, so that the reader will periodically send the data to the OpenTelemetry collector here. Now let's look at the client side of the example. It's simply first using HTTP and then instrument the HTTP. Note that this function will be, since we already have the package extension of HTTP extension.jl, so the instrument.jl will know how to instrument the HTTP service. And then we can try to send several HTTP requests at here. For the server side, similarly, we also using HTTP, and then we instrument the HTTP. Then we set up the handler, sleep for a random time, and also print an info message. Then we set up the router and also register router and bind the handler to the root path. And finally, we serve the start the service. Now, since I have already run the service before, we can try to take a look into here for the logs. Since I already have run it in the background, let's see the result correctly and set the exporter. And so here we can see the log messages here. And we can also check the traces, such. Not sure. Since it's already let's try the promises first. Okay, the promises seems okay. And the tempo, well, I'm not sure why it now exists. Well, okay, let's skip this part. And in theory, if you follow the tutorial at the website, you should also see the traces. So I will talk more about the best practice on using OpenTelemetry.jl. In production, we will try to leverage the environment variables, because in OpenTelemetry.jl, we have exposed most of the configurations through the environment variables. And it is best suited in the Kubernetes environments, so that you can configure those environments variables either through the configuration file, the deployment YAML, or through the Helm configurations. Several common configurations include the whether to enable or disable the OpenTelemetry. And you can also specify the endpoints and configure the optional parameters like the sampler or the timeout parameters. Besides, in production, you will usually want to avoid using OpenTelemetry directly because by default it will set up several default providers, and those might not be necessary in production. And it is recommended to always set up the provider in production explicitly. Some best practices on extending OpenTelemetry.jl. People usually would like to contribute code first through adding package extensions. So extensions should only depend on OpenTelemetry API.jl. It is not because that it is lightweight and with only minimal dependencies. It is also because that the OpenTelemetry API follows an official specification and it is quite stable. Also, you might also want to distinguish the sync and async cases. For async cases, you usually would like to end the span immediately and let the other service to decide when to end a new child span and send the span messages. Several real-world challenges I met. The first is we lack a gRPC server, and also the gRPC client doesn't support the protobuf.jl at version 1.0 yet. And the second one is writing extensions for existing packages are not that easy because the hook-related functionalities are always missing. Sometimes you have to manually do the injection, and unfortunately, we will encounter type piracy here. The third issue is, well, although I have used it in production before, but the newest version is not fully tested in production yet. And since I only use a fraction of the features in the latest version, so I'm not sure if there are bugs in there. And also, a very important part is the exemplar related are not important. This part, I think in Python, it is also not implemented yet. Another important one is that we need a better approach to pass the context information across tasks in Julia. Currently, we are still using type piracy again. Ideally, it should be passed like the log state in a task local storage, but we do not have a better choice here until now. And also, the performance bottleneck lies in the transportation layer instead of the extraction layer. Based on my benchmark results, the extraction and the serialization part is quite fast, and it's much faster compared to both the Golang and also the Python implementation. And this credit goes to the protobuf, especially the version 1 of the protobuf.jl. So how do we use OpenTelemetry.jl at Jigsaw? Jigsaw is still a working on project aims to help developers deploy scientific computing applications right in Julia and Python. So here we first receive a request from a client side, then we have a gateway written in the Python, and then the messages were passed to the AWS SNS and SQS through the Dapper, and the Dapper helps us to forward the message to the specific applications. And for all these components, the OpenTelemetry data will collected to a centralized place. Okay, thank you. This is my talk today. Any questions?
Okay, thank you very much. Actually, I did have a question, and I think I'm going to pose this to frames as well. One thing I noticed that we need is compilation logging during pre-compilation. And I was wondering if you have any thoughts about how we might accomplish that.
Could you be more specific?
How would we do logging during pre-compilation? As noticed, that's a problem that...
You mean compilation? You mean combine what?
When we're pre-compiling a package?
Oh, okay. Pre-compiling package. For pre-compiling, I think currently isn't. We haven't considered that part yet. Yeah.
Okay. Thank you. Are there any other questions?
So I saw that you had Prometheus in your Grafana instance as well.
Yeah.
And I was wondering, in the event that you don't want to implement an endpoint or so, you would push gateway. And if there would be a way to use OpenTelemetry to gather the metrics and then push them in some way to push gateway. I think the functionality is not there yet, but I was wondering how difficult that would be.
Currently, this package implementation is it is a pool-based, I guess, so that we open a port in our service, and so that you can use promises to connect to this endpoint. But also you have other choices. For example, here you can send the data without a promises library, and then you pass the data to the OpenTelemetry character. So this is a push method. And then from the OpenTelemetry collector side, you can use both push and pull approach to collect with the promises. Yeah, they are both supported.
Okay, here.
Hi.
Regarding the thing about moving data between different tasks, I know there's a pull request open to the Julia repository for something called context variables, which is exactly about that. I was just curious if you try that out and if you have any ideas about that.
I haven't tried all of that yet, but I will definitely give it a try later. Yeah.
Thank you. Any further questions for our speaker? Oh, here we go.
You mentioned doing like performance benchmarks. I wonder, have you published those anywhere? Is there a way we can compare performance?
Yeah, it is contained in the original repo, and we have a benchmark subfolder there.
Cool,
Yeah.
thanks.
Yeah. And also I've set up the CI/CD to run the benchmark. Yeah.
Okay. Last chance for questions. If not, let's give June another round of applause.